Hello friends, myself Saurabh Sharma. I am coming with the new questions, which is a wonderful question in this book. The question is number 10. This question is gives the idea about the drag forces on a fluid. Okay, so drag forces applied by the fluid bodies on the by the fluid body on the particular body. So, what is the question? Just read. Drag force of the fluid on a body is proportional to the velocity of the body relative to the fluid. Okay, a student drops several small identical stones from the different heights over a deep lake and prepare graphs between speed v of every stone in the water and time t. Okay, the graphs can be divided into three categories as shown in figure. Okay, which of the following explanation of this graph appears reasonable? The first option is saying that the first graph is for a stone dropped from a small height, and the second is a stone dropped from very big large. Okay, second one is saying similarly thing. The first is a large height, and second one is from a small height, and third one height sufficient acquired, and third graph is not possible. Okay, so I want to go and solve this question via very simple method. Let's In the question it is given that the drag force of the fluid body on is proportional to the velocity relative to the fluid. So let's assume just you can say that the Fv is directly proportional to V, and and you can say these graphs is showing that the V naught means V naught is the constant speed. So here V naught is constant speed. If the V naught is constant speed, means at this instant the acceleration on the body is zero. Acceleration of the body is zero means the drag force is directly equal to the weight of the body. So we can write the kV naught is equal to mg. Let us assume the k is constant. Very nice. So I don't know what is the situation, but if I'm writing a acceleration at any instant or any velocity except v naught. So acceleration of a body for v velocity means what I'm saying. Just look at please carefully. Suppose this is a water surface. Here somewhere the water at a height h, the stone is fall down. If a stone is fall down at a height h, then it will strike with some velocity v. So at this instant some forces is acting, so we can write the acceleration. So acceleration is nothing but it is mg minus kv by m. Okay, so acceleration we can write the dv by dt is equal to mg minus kv by m, and we want to integrate this velocity. So dv upon mg minus kv is equal to 1 upon m into dt. So integrate. At t equal to 0, the velocity is v, just instant, and at any instant the velocity is say called vt. Okay, so if you want to write at this instant, so you can say that it is 1 by k minus 1 by k ln mg minus k vt divided by mg minus kv. Okay, is equal to t by m. Very interesting expression will come. Mg minus kvt by mg minus kv is equal to minus k e to the power minus kt by m. Understood my point? Okay, so if I'm writing the velocity mg minus kvt, so we can write the expression, it is mg minus kv into e to the power minus kt by m. Okay, so finally you can say that the mg kvt is it is mg into mg minus kv into e to the power minus kt by m and minus mg. This is the negative sign. So if I want to write the proper way, so kVt is equal to, it is mg into 1 minus e to the power minus kt by m, one side, and minus minus plus kv into e to the power kt by m. Some expression is lengthy, but after you get the expression, you will solve this question with very easy method. E to the power minus kt by m plus v into e to the power kt by m. Okay, understood? If you release the stone from a height s, so velocity is under root 2gh. So just before hit the water surface, so Vt is mg my k into 1 minus e to the power minus kt by m plus v into e to the power, v is under root 2gh into e to the power kt by m. Okay, as we know, the mg kv naught is equal to mg, so we can write the velocity in terms of vt is equal to v naught 1 minus e to the power minus kt by m plus it is k, here it is k e to the power minus kt by m into square root of 2gh. Okay, just enters at t equal to 0, the velocity is this is entire e to the power 0 is 1 minus 1 is 0, this term is 0, so k into under root over 2gh. Okay, 2h. And if I am writing the value of k, then v is equal to mg by v naught into square root of 2gh. Now I am coming with the graph. Please remember this formula, this equation v. So v is directly proportional to h. So my dear friend, in this graph, the first graph is showing that if you are talking about first graph, then first graph, this point is more than v naught. This velocity is more than v naught. If this velocity is more than v naught, means this first graph, the h is, and this velocity is less than v naught. So this height is less than this height. So the first stone is dropped from the large height and the second stone is dropped from the small height. This is the answer B. And there is a sufficient height at this instant, immediately the V is required, the under root 2gh is equal to V naught. So there is also one more answer. Thank you so much for watching this video. Bye bye.